Okay, so Alan's talked about some science that helps us predict when outbreaks are going to occur. So that's, I guess, when to spray or when to control. I want to talk about how to control or what methods we can use. So the first one is copper. Copper is the obvious thing to test to control red needlecast. We've got a spray, operational spray program for Dothostroma needle blight. Wouldn't it be great if we could just transfer all that knowledge and the logistics into a control for a red needlecast program? So we did focus on copper, testing copper to see whether it had the ability to control red needlecast or not. In order to do that, obviously you need to assess its efficacy, and to do that, firstly you need to assess its efficacy, you need to investigate the optimal timing for the application, which is where Alan's work feeds in. And to do that you really need to assess disease. So we tried four methods to assess disease. One was just assessing trees from the ground, but that's subjective. It has between excessive variation. It's affected by light and weather condition, and now overcast conditions. It's really, really hard to see up in the crowns of very tall trees, and you get obscuring of symptoms through the subcanopy and branches, lower branches on the trees, the target trees, and it's time consuming as well. So what we did is we used an operational spray trial that was established in 2017, just a routine randomised block trial with spray applications in February and November, and a double spray in February and May. And from that, with all blocks, we looked at ground-based visual assessments. We looked at taking colour aerial imagery directly below, or having the target directly below the aircraft or the vehicles, the UAV. We also looked at oblique imagery and hemispherical imagery to look at, canopy density. And these trees were assessed in September 2018, 20 trees per block. And we looked at the percentage of crown with symptoms. And there was a hint, I guess, that copper reduces red needlecast severity, but it wasn't statistically significant, and there was no effect in spray timing. You'll note that the disease severity was maximum of about 10%, ranged from 8 to 10%, so that's very low. In fact, we didn't get a lot of disease in those trials, and that's normally effective life when you're putting in spray trials or trials to control the disease. You don't get disease. It's just what happens. When we looked though at red, green, blue aerial imagery with the point directly below, we found different results. So that assessment method was more sensitive or more accurate in establishing or assessing disease, and we did get some significant results. We found that copper did reduce red needlecast severity using that assessment method. Again, there was no effect in spray timing. So, to conclude, we do have evidence that copper reduces red needlecast severity. There was no effect of spray timing. Aerial imagery was a more effective method for assessing treatment differences than either ground method, but an oblique imagery where you're taking your image on the angle had the best correlation with ground scores, but there were line of sight issues. So really, from those trials and previous ones, I'm confident to recommend that copper application can control red needlecast. The trial was, affected by the low disease levels. It would have been fantastic just for that 1 year to have high disease levels so we could determine the effect of treatment differences, but I think we've got enough knowledge now to recommend that copper can control red needlecast, but obviously there's other methods. There's more long-term sustainable methods, and that's breeding. So I'll just pass on to Natalie now.